All right, what we're going to be covering today, and the homework from last time, just hang on to it, over the t-test stuff. We'll go over it, and we'll go over the assignment from today, both next time. Today, same kind of setup, hypothesis testing, but now we're doing for proportions instead of for means. Remember your proportion, that's your P for your population. Remember the stuff from binomial distributions. You got to check that n times p is greater than or equal to 5, and n times q is greater than or equal to 5. Remember, only check one of them. Whichever one, the p or the q, whichever one's the big or the smaller, check it. Most of these will be larger than 5, so you won't really have to check it. And remember that we're using p hat. P hat is your proportion for your sample. Other things to remember, n is just the number in the sample, p is your probability or your proportion, and then q is always 1 minus p. Again, there won't be a whole lot of problems that you'll have to do this. Most of them are going to work, otherwise it wouldn't make sense to give you the problems. But you should always start off checking, see if n times p is greater than or equal to 5, n times q is greater than or equal to 5. Otherwise, the binomial distribution stuff does not work. Z-test for proportion, Z-test for population proportion, a statistical test for population proportion can be used when the binomial distribution is given such that n times p is greater than or equal to 5. That's what we just talked about. N times q is greater than or equal to 5. The test statistic, or what we're actually testing, what we're using is p hat. Your z, your standardized test statistic, that's what we've been finding this whole time. The way we're going to find it now is by using this formula. P hat minus p. P hat, remember, comes from the sample. And the key thing on this whole slide here is this formula. That's what we want. And the P comes from probably your HO or your HA. It comes from what the original statement is. Then on bottom, it's P times Q. Remember, you find Q just by 1 minus P divided by n, and you take the square root of all of that. So this is probably a better way to write that. And this is a little harder formula. You have to do these. If you can figure out how to do it on your calculator, all is one thing, then that's fine, as long as you're getting the correct answer. But when I do it, I'll probably do the bottom first, write down the answer, do the top, write down that answer, then divide the two. So you might have to do it in parts just to make sure you're getting the right answer. But that's the formula that we're going to be using on this. Basically, this is the same stuff that we've been doing. Remember that p hat is always x. This is the number of yeses divided by the number in the sample. So x is the favorable outcomes. N is the total outcomes in the sample. Sometimes you may have to find p hat on your own before you can actually do the other stuff. There is no calculator method, and I'm not lying this time. So you have to find z on your own. So you have to use the formula. Whereas on the first two that we did, you could find the z or the t, either one, on the calculator. This time you have to find it. Again, we're going to be using the rejection regions mostly. You could use comparing z to alpha again, But the rejection region, since we've been using that the whole chapter, that's what we're gonna basically stick with. That's what I'll stick with. To do this, I'm gonna put these up here. So first thing, same idea, first thing you do, you state your HO and your HA, state your null and your alternative hypothesis. Identify your level of significance, your alpha. They're going to tell you that most of the time. Number 3, draw the picture. Same as we've been doing. Number 4, you're using your Z chart, which is the front 2 pages, or probably the small chart that's at the bottom right, the one that says left-tailed, right-tailed, and two-tailed. And then if you're using that small chart, then we really don't have to worry about all this stuff so much, because it's right there on that little chart that I made up for you, so that you don't have to mess with that every time. So those are the first 4 steps. Basically the same thing as we've been doing. The next steps, number 5, just part of the drawing. Put in your rejection region, so draw your little bar here and shade if it's left-tailed, right-tailed, or two-tailed. Number 6, then you got to use the formula. You can't use the calculator on this. Again, doesn't have a calculator form, so you have to find Z using that formula. Number 7, decide to reject the HO or fail to reject the HO. So you decide whether you reject or fail to reject for step 7. Just switch back on me. I'm crazy. Oh, no, hold on. Sorry. I'm going the wrong direction. And number 8, you interpret. Remember, when you interpret, you have 3 parts, and you're going to use that chart that's in your charts that tells you there is enough evidence, there is not enough evidence, so you're going to use that chart. So that's your 8 steps. Not sure why I put this on here twice, but this is the same stuff. So you state your HO, your HA, find your alpha, determine your standardized. I think I just redid it and put the drawing, the curve, and all that stuff in there. This is a better form for the formula, just so you don't mess it up. Use the table again, use that little table probably most of the time. Oh, this is why I put it in here twice. So if you're using the p-value, which we're not going to do, use the p-value, then you compare the p-value to your z, and you could go from there. Remember, if p-value is less than or equal to alpha, then we reject the null. If your p-value is greater than alpha, then we fail to reject the null. Again, I would rather use you can use the p-values if you want. I would rather, and most of the stuff I do, I'll be using the rejection regions. Zogby International claims that 45% of the people in the United States support making cigarettes illegal within the next 5 to 10 years. You decide to test the claim and ask a random sample of 200 people in the United States whether they support making cigarettes illegal within the next 5 to 10 years. Of the 200 people, 49% support this law at a level of significance of 5%. Is there enough evidence to reject the claim? All right, so first thing we do, we check to make sure that we can use the binomial setup. So we take 0.49 and we times it by the 200, and that should be greater than or equal to 5. Well, 50% of 200 is 100, so this most definitely is going to be greater than 5. And if we check Q, Q would be 51%. We just subtract it from 1, we times that by 200. It's going to be greater than 5. So it works out as far as the binomial goes. Then we just follow our steps. We write our HO and our HA, our HO, HA, and I'll write these, then I'm just going to jump to the next slide and show you the solutions and stuff. It says Zogby International claims that 45% of the people in the United States support making cigarettes illegal. So with this, it's saying exactly 45%. So they're saying that 45%, so that means that our P is equal to 0.45. That's our claim, and it goes in our HO. It goes in our null hypothesis. Then our HA is going to be P that's not equal to 45%. So that's our HO and our HA. And I'm just getting these numbers down to make sure I know alpha is 0.05, just so when I go to this next slide I can have that. We already did the verification there. So our HO was P equals 0.45. Our HA, notice it's P and not mu now. We're doing P's. Our alpha is 0.05. Next, we're going to draw our little chart. So we draw our little chart. And since we look right here, that tells us that we are two-tailed. We go to the little chart on our graph, and we're going to find these two numbers. We look under two-tailed, and alpha is 0.05. And we get negative 1.96 and 1.96. These two numbers come from the little chart on the front page. Then the next thing we do is we find our Z. And I've already worked it out here, but again, when I do this, I plug in all these numbers, just like this right here. I write that down every time. Then I find out what's on top, 0.04, and then what's on bottom. Punch all of that into your calculator, find it, then divide the two. And we come up with approximately 1.14. And we look and see where that's going to fall. Well, it looks like it's going to fall somewhere about right in there. And that tells us to fail to reject the null. Then once we fail to reject the null, we're going to do our three parts. First part comes from our alpha. So we say with a 5% level of significance. Then we go to the chart and say there it is, and we look it up. The claim was the HO, and so we look in that column and we match it up to failing to reject the null, and then we tie it back to our problem. So at a 5% level of significance, there is not enough evidence to reject the claim that 45% of the people in the U.S. support making cigarettes illegal in the next 5 to 10 years. Pew Research Center claims that more than 55% of U.S. adults regularly watch their local television news. You decide to test this claim and ask a random sample of 425 adults in the U.S. whether they regularly watch their local television news. Of the 425 adults, 255 respond yes. First thing we're going to have to do on this problem is find our p hat. Remember, p hat is your favorable over your total. So that's 255 out of 425. So 255 divided by 425 is 0.6. So our p hat's 0.6. That means our q hat is 1 minus that, or 0.4. Then we got to check to make sure that it fits the binomial setup. So on the binomial setup, again, we just do n times p or n times q. Q hat, and I'm sorry, that shouldn't be p hat. I know this is p hat and q hat. So we're just going to take 0.6 times we're not going to take 0.6 times, we're going to take their claim. Their claim was 55%. So we're going to take Q would be 0.45, so I'm just going to do 0.45 times our N, which was 425. And as long as that's greater than or equal to 5, then we can use this stuff. And that is going to be, 50% of 400 is 200 and some, so it's going to be most definitely be greater than 5. So this checks out. Again, most of them are going to check out, so that's not something that we really have to worry about a whole lot. So we check it, and it comes out to be that, so we can use the binomial setup. Next thing that we do have to have those, we have to have p hat, which is that, and q hat, which is that, so that we can do all the rest of the stuff. We're going to write our HO and our HA, then I'm going to switch to the next slide, and we'll just do most of it. Our HO, let's see, it says the research center claims that more than 55%. So more than 55%. That means that our P is greater than 55%. So that's going to be our HA. P is greater than 0.55. And that means our HO, our null hypothesis, is less than or equal to 0.55. I forgot, this is our claim. Make sure we write that down. Once we have those two things, we're going to look, we're at 5% level of significance, so we're going to use that. We found our P hat, which was 0.6. We found our Q hat, which was 0.4. And we're going to use that stuff. Make sure I did this right. So this was your claim. And I forgot it on here, so make sure you do that. Your alpha, your level of significance is 0.05. Now we're going to draw our rejection region. We look here for that again. That tells us that we are right-tailed. And we're going to look up on that chart on that front page of your packet. Look up 0.05, one-tailed, and find this number for our rejection region. It comes out to be 1.645. Then our test statistic, we use that formula. Again, there's no way to do it on the calculator. You have to write out the formula and do it. We found p hat. P hat here was 0.6. So we do 0.6 minus 0.55, which is 0.05. That's on top. Then on bottom, if I punch all that into my calculator, second square root 0.55 times 0.45 divided by 425, and I get 0.02413199. Then I'm just going to divide that answer, 0.05, divided by this bottom answer, which is 0.024133199, and I get 2.0719. I get that. Then I look at that. That's going to fall somewhere about in there. That tells us to reject the null. Once we reject the null, then we're going to do our interpretation. Our interpretation again is going to start off with a 5% level significance, and then we go to the chart. We look up reject the null and the HA, the alternative hypothesis, was the claim. So we look those up, match them up, and it's going to say at a 5% level significance, there is enough evidence to support the claim that more than 55% of U.S. adults regularly watch their own local television news station or news program. The assignments on page 401, problems 3 through 11, 13, 17 through 19.